Hello everyone, my name is Aaron Standard and I hope you all had a great Christmas. Today we're going to talk a little bit about episode 2 of Why Your Software Sucks, with a focus on inheritance this time. Now, I don't want to make a habit of starting every one of these videos with a Twitter thread, but here it is, and I'll go ahead and include a link to this in the description. But the gist is that myself and Rodney and Jim, all three of us are all friendly with each other. We all know each other from the .NET open source ecosystem. We're having a little discussion about, is inheritance fundamentally a contributor in code bases generally not performing very well? And by that, I mean they have a lot of technical debt. They aren't very easy to change, aren't very easy to follow, aren't very easy to maintain, etc. And my arguments for why I think inheritance is generally a drag on most code bases effectively boils down to the following. And I go into this in a little bit more detail in this blog post I'll pull up in a minute. The gist of this is that deep inheritance hierarchies, once you start getting more than, a base class plus implementers, once you start getting 4 or 5 base classes down, it becomes very difficult to trace where behavior comes from inside the application. Why did X do Y? That type of question gets a little bit more difficult to answer. You need to start stepping through more and more code, and the cognitive load of reasoning about it actually becomes quite a bit higher. Multiply this by the fact that these classes can have mutable internal state, and it gets a lot harder from there as well. The other thing that becomes really pernicious about deep inheritance hierarchies is you can end up with the dreaded everything touches everything architecture, where someone decided it was a great idea that to come up with a universal model for how things should all behave within your software domain. Generally speaking, that approach is almost always doomed to fail, even in the hands of experts, unless you know your domain is very unlikely to change and you're expertly good at scoping out and anticipating how it might evolve in the future, and you have a plan for kind of having the code base evolve along with that. Those are two things that software developers generally struggle with. So it's the exception, not the rule. So generally speaking, when you start with these really deep inheritance hierarchies, you eventually end up getting into what I call configuration toggle hell, where because you have a universal base class that everything inherits from, and this base class, in order to be valuable, has to be a little opinionated. Well, when those opinions stop fitting the actual needs of each domain object, that's when the configuration toggles creep in. So let me go ahead and give you an example of that from SDKBin's own code base here. All right, so this is our startup class for ASP.NET Core. Now, we started building this application before things like minimal web APIs were a thing, so we still have startup. We don't have this all chaining off of the web host component or whatever. We still use an old-fashioned startup. And the original developer who built this created, now bear in mind, there's only 2 distinct services inside SDKBin. There's our user service, which is what controls our access controls, and is also where the buy path is for people to purchase. And it's also kind of generally the more complicated of the 2 services. And then on the other end, we have the NuGet service. The NuGet service is responsible for basically serving up a NuGet v3 API. It is much higher traffic than the user service, and it also deals with much larger files. So these 2 services have very different traffic requirements, and therefore, that might be a good reason for their configurations to look a little different. Now, a question I can't answer is, why do I have like 5 layers of base classes here? So this is the actual startup class for our user service. And you can see here, these are the little configuration toggles. We have our enable bearer header and swagger, enable authorization, the database connection string name, use lowercase routing, some automapper stuff. Don't even get me started on that. And then finally, we have our real system for being able to configure things like file uploads and all that jazz. Well, if we step into this, we have a service startup with database. All right, let's step into that. This takes an entity framework core context. We have this abstract property that needs to be filled in, and we use this information to go ahead and configure EF core. So why do we need an entire base class for that versus just having an extension method do it? Don't know. I didn't design it. And then we have, we're not done yet, another base class, the service startup class underneath this, which defines a cross-origin request policy and has a couple of other properties down here. This defines all of our configuration toggles, etc., etc. This is a very simple class ultimately in terms of what it has, because most of the behavior is defined via these extension methods we register on the iService collection. That's kind of the standard pattern we use in a lot of .NET software development. But what I find to be sort of indicative of a problem we're going to run into here is this universalism, and also this sort of preemptive need to go and create these base classes before we've even served our first live request. That is indicative of a really negative trait software developers should avoid, and inheritance is the gateway drug that opens this door: frameworkism. Now, I've got a whole blog post, and I will probably refer to this during many episodes of Why Your Software Sucks, because this is one of the leading things that causes it to suck. But frameworkism is this notion that I can take a fairly complex business domain and come up with a universal model for it, expressed via a bunch of highly opinionated code components. Therefore, I don't have to do a lot of hard decision making about how to model domains. The framework will kind of lend itself into that. But there's a bunch of fatal conceits that come with it. Namely, it rarely works. And it causes the following problems. These are the 3 reasons why frameworks don't work. The first is preemption, trying to create the framework before you actually are trying to do anything real inside your software. So if you have this sort of imagined scenario for how your application is going to work and how it's going to be built and how the different requirements are going to look, and you try to create a framework for that before you're actually meeting the needs of stakeholders, it's going to fail. It's basically designing in a vacuum, and it's not meeting the test of reality early enough. Frameworks tend to work pretty well when they're extracted from an application that works, where if you notice, hey, we've got 3 completely different components for constructing transactional emails. Maybe we should standardize this and have a little library that allows us to do this on the fly, and I can kind of assess where the commonalities are, and I can add some, thin little inheritance layers here to kind of allow customization where it's necessary. That would be a much healthier approach for building a framework. That's not generally how it goes. Usually it's done preemptively, which is bad, leads to bad things. But the real sin, which is what we're talking about here, is rigidity. The sin of rigidity is that you come up with a universal model for how things should behave. And this is designed to help make your decision-making simple. It's going to essentially be opinionated and steer all of the different vectors of your, let's say, domain all in the same direction, ideally. The problem is reality doesn't work that way. Different things are different. As a result of that, when your universal model starts to break down, that's where you end up with these dreaded configuration toggles here, where I need to use lowercase routing on my user service, but not on my NuGet service. Or I need to use cores on my NuGet service, but not on my, and you kind of see where all this all goes. It ends up becoming a bit of a ball of mud from there. And then finally, there's predetermination, which is basically talking about using the exact set of tools for every single problem, regardless of requirements. We will do a whole video about that by itself at some point in the future. But what I'm trying to show you so far is this is where the configuration toggles begin to creep in. But it gets even worse than this as we start digging into this sort of pattern of trying to use inheritance to solve modeling problems across very different looking concerns inside the system. Here, we're just using it to address how we configure an application, an ASP.NET Core application. And this isn't that bad in the grand scheme of things. The next example I'm going to show you is so much worse. Inheritance is a gateway drug for frameworkism, and you can kind of see the makings of that here. So this is our buy page. This is the only real page on the site where we need to actually have money exchange hands using our Stripe integration a little bit further down. And this page is a bit of a mess. We're refactoring it at the moment. But what I want to show you is the 5-layer deep inheritance hierarchy this thing sits on top of. So we have, our actual page itself. Underneath that, we have this customer page base, which has a couple of, convenience methods for basically generating results to like redirect the user back to the home page or whatever, that's okay, I guess. But where it gets kind of nasty is when we dig into another layer deep, our organization page model. We have 2 different types of organizations in the system: publishers who sell, and then customers who buy. And down here, we basically have a requirement that we inject this iOrganization repository and this iAuthorizations service and this iHost environment. And we use that information to basically perform some authorization checks, namely to basically make sure the organization exists and this user is who they say they are. We have replaced this in our ASP.NET Core controllers we're introducing to try to get rid of Razor pages. We've replaced this with a dynamic stacked authorization service where I can write a really simple sort of claims expression, and that gets validated using ASP.NET Core middleware. So that doesn't need to be sprinkled into the page anymore, and we can also support much more granular scopes now than we used to. So this was super wasteful, required extra database round trips, and generally sucks. And we're not done with the inheritance hierarchy yet. We have the page-based model, which takes the iHost environment, and one of the other evil things this code base will do is engage in implicit configuration. If we are in the development environment, we will go ahead and start turning certain things on or off, which means that locally it can be very difficult to understand what your configuration is and how that might differ from production. So don't do that. Don't do implicit configuration either. That's a whole nother kettle of fish. And then finally, we have the real ASP.NET Core base class here. So 5 total layers of inheritance to deliver this page. Now, what makes this so pernicious and somewhat damaging to the integrity of this code base is that it introduces this sort of everything touches everything architecture, namely this organization page model right here has a really strong opinion on what our dependencies should be and how to basically enforce, does this user belong to the organization or not? So as a result of this sort of infrastructure here, trying to migrate any of these pages from not using these repository types anymore is really difficult because it touches so many different little layers. Every single one of these pages relies on having its organization preloaded in advance into the model. And it basically just kind of creates quite a bit of friction to migrate from, let's say, a CRUD repository, which we're going to get into that in a second, to using something like a CQRS presentation of all this user's information. Because of how strongly opinionated these base classes are, we basically have 2 options for how we want to address architectural problems like this. The first is to essentially rewrite the base classes themselves, and that potentially nukes all of the other downstream dependencies. That is a high blast radius change. We don't want to do that. That's pretty destructive. The other approach is to gradually migrate away from using these base classes and use something else entirely, which is what we're doing here. We actually are ditching Razor pages in its entirety because it has a whole bunch of other limitations that aren't really relevant to this video that generally kind of make it non-desirable. But we're moving towards more of an MVC sort of approach for actually reorganizing the rest of the user service in particular. So that's one example of where like having a deep inheritance hierarchy can kind of make it very difficult to maneuver and change things. In this case, the solution is to simply stop using it, which is what we should have done in the first place. We never should have had a 5-layer deep inheritance hierarchy. So the other evil sort of inheritance implementation I want to take a look at here is the infamous, dreaded generic repository. So we have our organization's repository here, and it has all these CRUD models that call down to a base class implementation stored inside repository base. And then we have a couple of, let's say, private methods that get called for get organizations queryable. And ironically enough, the reason why these methods are necessary is because the base class can't express what it is we need to do to retrieve the information that goes into an organization. This repository base class is evil for a number of reasons. So basically it requires, our EF core context. It requires automapper, and that is heavily inserted inside the way this base class does everything. God help us. But the thing that makes this code base truly evil is that the generic repository implementations here were really designed around the idea that an object equals a single row in a database. Well, as you can see from things like an organization, organizations are actually fairly multifaceted objects. You have all the people who belong to the organization, you have the display and billing address, but more importantly, it's kind of ironic that we needed this because the base class's default get mechanism can't actually do this. So you have to add your own methods and then call them inside these little interface specific get organization by ID. And for some reason, why are we, okay, so I guess we are using the base class method here, but we're not using it here because this is a queryable. Is that why we're doing it? We're trying to get rid of this code because it absolutely sucks and is horrible. It's non-performant. It's buggy. We're mixing reads and writes inside the same class here. This code base, even though it's not very high traffic, is sophisticated enough where we are actively harming our ability to express our domain requirements by having really blunt abstractions like this repository base class here. So in this case, the sin of inheritance we're committing isn't so much having a deep inheritance hierarchy as it is having a really rigid one where it tries to do way too much. So the real gist of this is that while inheritance isn't always evil, when you start using it pretty heavily, you're going to end up creating these little pits of doom where you end up either having high blast radius changes. When you have that everything touches everything design, that's how you know you're dealing with one of those. Or you're going to end up having to dig through like 6 layers deep of code to figure out why does X produce Y inside your code base. So the general gist of this is that what we should try to prefer is runtime composition. Go and compose all the different little agents that make up our feature. That would be how much more highly preferable than trying to have these big opinionated base classes. Like, let me show you how just how big this method is here. This class is, let me scroll down to the bottom. This is our generic repository base class, and it has 866 lines inside of it. It has some JSON serialization stuff that I don't understand at all. It's got a whole bunch of unused methods here. This kind of harkens back to our first video in this series about junk drawer code. A lot of this stuff was never used. It was all built kind of preemptively, anticipating needs that we don't actually have. And so it's a lot of code to maintain, a lot of moving parts, very highly opinionated. And if our requirements change, which they have, we're trying to do much more sophisticated stuff inside SDK bin, like adding the support for new fulfillment types other than NuGet, for example. And we're trying to add new billing types as well. This design actively impedes our ability to express those in our software domain because it was built around a very narrow set of requirements and is not very good at basically scaling to support complexity in the growth. It's not very well suited to scale up to supporting more complex domains, which is inevitably where software goes once it wants to get used in more places by more people and more contexts. So this concludes our second episode of Why Your Software Sucks. Be careful with inheritance. It's not universally bad, but generally when people start using it a lot, they're usually doing something stinky. So you might want to go ahead and double check and make sure you're not doing anything untoward inside your code base here, using a couple of the examples I've just given you. All right. Have a good rest of your year. This will probably be our final video for 2025. We will catch you in 2026. Don't forget to like and subscribe. Thank you. Well, that'll do it for this video. If you found this video useful, please don't forget to check the description to find links to other resources we may have included. So blog posts, GitHub code samples, other videos, so on. And as always, don't forget to like and subscribe and ring the bell for notifications. We'll catch you next time. Thank you very much.